Today I'm going to talk about the derivative of composite function, one of the chain rule, general power rule. Okay, so when we do the derivative on composite function fx to the power n, that equal n times fx to the power n minus 1 fx prime. Okay, and the difference between general power rule and power rule is we have the extra term fx prime. Okay, fx prime. Now the key part for the general power rule is to identify what is fx. Okay, if we find the fx, that means we can directly plug in here. Okay, so before I'm going to solve the following 4 problems, I would like to recall 5 formula that can be used. Okay, the first one is derivative of a constant, that is 0. The second one is standard power rule, that is n times x to the power n minus 1 and x prime equals 1. Okay, that's a special case. Third one, if we have a multiplication of a constant and a function, and the derivative of this guy gonna be keep the constant the same, and we do the derivative for the fx. Okay, and the fourth, if we have 1 over a to the power n, that should be a to the power negative n. Fine. If we have nth root of a, that should be a to the power 1 over n. So we have 5 formula here. Now let's take a look at the first problem. And for the first problem, we wanted to identify what is fx, and we can find fx is 3x plus 1. Okay, and of course we know the n corresponding here is 4, right? So we're gonna plug in fx equals 3x plus 1 for this formula. So equals fx 3x plus 1 n minus 1, so it's 4 minus 1 times fx prime, so it should be 3x plus 1 prime. We can simplify it. We're gonna get 3x plus 1 cube, and here we have derivative of binomial. That means we're gonna do the derivative for each monomial. Okay, do the derivative for each monomial, and then we have what? For the first term, we're gonna follow the formula 3. K is 3, is a constant. Keep the constant. Do the derivative for the x. Okay, and the second term is derivative of a constant following the formula 1. Okay, now we can simplify it. Derivative of x following formula 2, that is 1. so 3 times 1. And we can simplify it. 4 times 3 is 12 times 3x plus 1 cube. That's it. Now let's take a look the second example. We can easily identify the fx. Fx equals x cubed plus 4. And we can plug in the formula. Okay, so fx x cubed plus 4, the n equals 7, right? So we plug in here. So 7 times fx is x3 plus 4 to the power n minus 1. 7 minus 1 times fx, that is x cubed plus 4 prime. And we can simplify it. X cubed plus 4 to the power 6. And again, we do the derivative for the binomial. So we're gonna do the derivative for each monomial. Okay. And we can simplify it. For the first term, we're gonna follow the formula 2, that is power rule. We're gonna get 3x, 3 minus 1, and the second term should be formula 1, that is 0. Okay, and we can continue to simplify this guy. And 3x to the power 3 minus 1 should be 3x squared. So that means 7 times 3, 21x squared. And x cubed plus 4 to the power 6. Okay, we finish the second one. Now let's take a look the third one. 1 over x squared plus x plus 1 to the power 3. We don't like the rational expression, so we want to convert it. How to convert it? We're gonna follow the formula 4. Formula 4 give us 1 over a to the power n equal a to the power negative n. Okay, so here we can treat x squared plus x plus 1 as a, right? As a. So we can convert it. We can convert x squared plus x, that is a, okay, equals a to the power negative n. N is 3, so here is negative 3. Now we can identify what is fx. So the fx can be written down as x squared plus x plus 1. Okay, and we can either tell the n is negative 3, right? So we're gonna plug in the formula n negative 3 fx x squared plus x plus 1 to the power n minus 1 is negative 3 minus 1 times x fx prime, right? Prime. Okay, and then we can simplify it. We have negative 3, negative 1, negative 4, and here we do the derivative for the trinomial, right? So if we do the derivative for trinomial, that means we're gonna do the derivative for each monomial. Okay, each monomial, and then we can simplify it. And for this term, x squared, we can follow the power rule or formula 2. That is 2x to the power n minus 1. And the second term, x to the x prime equals 1. Derivative of 1 is 0. Okay, and then we can simplify it. Negative 3 2x plus 1 x squared plus x plus 1 to the power negative 4. Okay, so for the last term, x squared plus x plus 1 to the power negative 4, we can use the formula 4 again. Okay, so if we have a to the power negative n, we can convert it to 1 over a to the power n, right? So we can write down negative 3 2x plus 1 divided by a to the power n. So x squared plus x plus 1 to the power 4. Okay. Now let's take a look at the last example. And again, here I have a square root. We don't like the square root, so we're gonna follow formula 5 to convert it to a to the power 1 over n. Okay, so here is a square root. That means what? That means we can convert it to 3 minus x to the power 1/2. Okay, then we can identify the fx. That is 3 minus x. So we're gonna plug in here. The n is 1/2. We just copy it 1/2, and 3 minus x to the power 1/2 minus 1 times fx prime. Okay, and again we can simplify it, and for this guy, do the derivative for the binomial. We're gonna do the derivative for each monomial, right? And here the derivative of constant equals 0, derivative of x equals 1, negative 1. So we will have negative 1/2 3 minus x to the power negative 1/2. Okay, and again here we have negative, so we can use the formula 4, right? Actually it's a reverse process, so we can write down or put this guy in the denominator. Okay, just put this guy in denominator, and the negative 1/2 becomes positive 1/2. Just follow this formula. And again, now we can tell 3 minus x to the power 1/2, just like formula 5, 1 over 2, right? 1 over 2. So we can use formula 5 again to convert it. That will be 2 times square root 3 minus x. Okay, 3 minus x. That's it.